anyways. All right, so first one we're going to talk about today. What do you think WS is called? We only have 2 words left. So out of the 2 we have left, what do you think it's called?
It's perpendicular bisector.
Cool. So this has 2 words. The word perpendicular and the word bisector. Ashley, what does perpendicular mean? This first one. 90 degrees. So what symbol would our picture have if it's perpendicular? The box. So 90 degrees, it's got to have a box. Kids, what does bisector mean? Perfect. Cuts in half. So what symbol would our picture have if something's been cut in half? Tick marks. So if you are a perpendicular bisector, you don't have just one symbol. Altitude has just one symbol, a box. Median has just one symbol, tick marks. But if you're a perpendicular bisector, you're both. What's that animal that's like both a human and a horse? Centaur, minotaur, something tar.
It's a tar something.
So it's a combination of both. It's like a hybrid. This is a hybrid, altitude and median. It's altitude and median in one. Now, this looks different than all the ones we did yesterday. What's different about that segment?
It's like just anywhere.
It's just anywhere. What'd you say? Oh, dotted. I think they were dotted yesterday. Yesterday, it started at an angle and it ended at a side. Does this one start at an angle?
No, it ends.
No, it's kind of just hanging out in the middle of the triangle. Like Megan was saying, it's just kind of anywhere. So that's unique about a perpendicular bisector. Fill in your notes. Fill in your notes. Perpendicular bisector. It's a long word. You're going to have to write small. You can put the upside down T. You can put upside down T. A perpendicular bisector, a line segment array that's perpendicular to the segment at the midpoint.
Why do I confuse my
This one does not necessarily go through a vertex. We're right here. It does not necessarily go through an angle. Sometimes it does. Sometimes it goes through an angle, but most of the time it doesn't. Okay, let's practice drawing them.
No.
Draw a perpendicular bisector of BC. So here's how you draw it. You find side BC and you find the midpoint. Perfect. Everyone find the midpoint of BC. Put a dot and put tick marks around it. Then instead of connecting that to the letter A, you just go straight up. Very good. You just go straight up and down and you put a box. And that is a perpendicular bisector. So you got to find the middle, and then you got to draw a line that's 90 degrees to that side. Something cool happens when we do this triangle. What kind of triangle is this, by the way? Equilateral. Very good. So if I find the midpoint and I draw a dotted line through the midpoint, I do go through an angle. So that's a special case. Special case. Yeah, you can write special case if you want. You can star it, special case. All right, this one. Find the middle, put a dot, put tick marks around it, and dotted line. And a box. I forgot my box here. Okay? Awesome. Candy bar, airhead, it's Sprite. I'm never going to cease to be amazed by how much junk food you can eat. Okay, so we said that triangle was a special case. We put a star around it. And Kenneth said what type of triangle it was. What type was it?
Equilateral.
Equilateral. There's one, does that disappear? No, not one of the ones that disappear. There's one other time when a perpendicular bisector goes through an angle. There's one more special case. A right? No, because we drew the right one. Not obtuse. Not scalene. Not acute. Isosceles. Are you writing this down? Those are your 2 special cases. And when it's not a very big box. When would it go through a vertex? Isosceles and equilateral. It's a very small box. Sorry. When would it go through a vertex? Isosceles and equilateral. All right, special cases. I'm going to get my highlighter out. Who would like to come to the board and highlight the perpendicular bisector? It's fun. Highlight? Come do it. You can name it on your paper. Name it. Name which one is the perpendicular bisector. Name it. Is it this one? Yeah. Ooh, yay. Can you name it too while you're up there?
VS?
Yep. Capital V.
Yeah.
Capital S. No, that's fun. No, do it like that.
Okay.
Capital S with a segment on top. Very good. Thank you. Yay, Danica. All right. Why didn't you write it down? Write it down. VS, SV, either way. If you don't want to call it VS, you can call it SV. That is the perpendicular bisector. Why do we care about perpendicular bisectors? Who's ever walked into a room and a picture was like kind of a little bit off and it really bothered you?
It gets under.
Oh my gosh. So anyways, if you have a picture frame, a lot of picture frames don't have things to hang it like that anymore. But if you did have a picture frame and you were hanging it, oh, like mine right here, like with a cute little ribbon or something. Like a stain on it. Anyways, so if you wanted to make sure that that was perfectly straight and it wasn't a little bit crooked and so it didn't bug you, if you wanted to, you could find the exact middle of the picture frame and you could go straight up 90 degrees, and that's where the nail would have to be put. You could put it anywhere along that purple line. You could put the nail here, here, here. As long as it's on the perpendicular bisector of the frame, then it'll hang perfectly. That's where you put the nail, if that's exactly where you want the picture to be. So anyways, there's a real world application. All right, go to the bottom. Triangle OAL, or actually it's GOA. Goal! Oh! Goal! Okay, no, okay. Anyways, OL is a perpendicular bisector. Jeanette, what should I add to my picture? Two things. The word perpendicular, what should I add for that word? You do know, you know. Yasmin, what should I add for the word perpendicular? A box, a square, whatever you want to call it. And Dimitri is not here. Danica, what should I add for bisector? Okay, everyone do it. Add a box and tick marks. 90 degrees and midpoint. Okay, GA is 12 and angle A is 25. So mark up your picture. This is 25 degrees. This is 12 inches. A lot of people tend to get sides and angles mixed up. They're totally separate, so never mix sides and angles. Find the measure of angle AOL. So this angle right here. What kind of triangle is this purple triangle? Nope, this purple triangle. It's a right triangle. Very good. So you add up 90 plus 25 and you subtract it from 180. Lewis, what'd you get?
65.
65. Perfect. AOL, 65. You add up the angles and subtract it from 180. 90 plus 25 minus 180. Never get a negative answer. So if you accidentally put that one first, you'll get negative 65. Just make it positive. All right. Julius is not here. Megan, how long is GL?
50.
So GA is 12. How long is GL?
25.
Huh?
25.
Okay, well, see, we're not going to mix up. This is an angle, whereas this is a side. So we're done with angles. Don't look at the angles anymore. If I said this was 12 and then I cut it in half, how much would it be? 6. There you go. GL is 6 inches. And therefore, everybody, LA is 6 inches. 6 and 6. Okay. 6 and 6. Because they gave you 12. 12 was given. Ashley's taking a nice nap. Okay. Moving on. Number 2. OT is a perpendicular bisector. Add markings to your picture. Add a box and tick marks. Add a box and tick marks. GT. Or OT. OT. Ought. Ought. You ought to add a box and tick marks. Wait a minute. A perpendicular bisector is going through a vertex. What does that mean? There's only 2 times it does that.
Special.
It's either equilateral or it's isosceles. We don't know which one it is. It's either equilateral or isosceles. But either way, whether it's equilateral or isosceles, whether it has 2 sides congruent or 3 sides congruent, either way, don't you agree that this side is going to be the same as this side, whether it's isosceles or equilateral? So what do we do with the 4x and with the 36? Not add. Set them equal. They're equal. It's isosceles. They are equal. Travis, what is x equal? 9. Very good. 36 divided by 4 is 9. Last segment. Ready? Last segment. What is this segment called?
Angle bisector.
Angle bisector. Let's fill it in. An angle bisector is a ray. It's a ray that divides an angle into 2 congruent, I don't even like this word, 2 congruent parts? No. 2 congruent angles. Divides an angle into 2 congruent angles. It's only first period.
I know, that's why.
You got a big day in front of you.
Today does not seem like
It doesn't?
This is the longest.
Is it a pleasant surprise? Why? Oh my gosh, that's dramatic.
I hate it this week.
Oh, let's be positive. This week is over. It can only get better from here.
It's only over when we leave.
I hate it.
Girls!
Oh
my gosh.
time for 6 weeks.
Did you know that if you are positive and you smile, even though you're feeling bad, it'll just make you feel better? Like make it, like fake it till you make it? Okay. All right. Practice drawing an angle bisector from angle B. So take angle B, eyeball it, cut it in half-ish, draw a ray, and put arcs. Go. Draw a ray, put arcs. That's an angle bisector. Cut that angle in half. Divide it in 2. Draw an angle bisector from angle B. Do it again. Woo! Arc, arc. From angle B. Stop shaking, whiteboard. Arc, arc.
Wait, why are you supposed to put an arc there if it's a right angle?
Well, a right angle can be cut in half. It can be. What would each angle be if I cut a right angle in half?
45.
It'd be 45 and 45. But you can still put arcs there to show that you did cut it in half. Because you could also, Megan, take a right angle and you could not cut it in half. And this could be 30 and 60. So to show that I really did cut it in half, that's why I put the arcs. All right. Which segment is an angle bisector?
No.
AE. You gotta look for the one that has the arcs around it. Capital A, capital E with a, technically you're supposed to put a ray on top because an angle bisector is a ray by definition. I'm losing Ashley and Kendall. We gotta play basketball soon. All right. And you know what words are behind here, right? What words are behind those walls? Isosceles and equilateral. In isosceles and equilateral, when you're one segment, you are all 4 segments. When you're 1, you're all 4. So if I draw a segment here, straight down to the middle, that's not just a median. That's a median, that's a perpendicular bisector, that's an angle bisector, and it's an altitude. When you're one segment, you're all 4 segments. But that only happens for isosceles and equilateral. When you're 1, you're all. Okay. My example, this falls perfectly because the World Series is going on right now. I have a baseball example. So in my baseball example, when they are designing a baseball field and they've decided, hey, home plate is going to go here. And then they put first base and third base and they make a nice right angle. And then they're trying to figure out where exactly to put the pitcher's mound and where to put second base. Well, guess what? They fall, both of them fall on the angle bisector of where the home plate is. Perfectly in the middle, right? It's got to be in the middle or else that wouldn't be fair. This has to be equidistant from here and equidistant from here. So it falls on the angle bisector. So there's angle bisector in the real world for you. All right, last problem on our whole